Users already type the filter's price, size, brand. Parse them, and your bool query stops guessing. By the end, you will understand how to turn messy search phrases into exact filters and soft boosts, so results match intent, not guesses. I'm Professor Pi, teaching search and IR with simple Python. Search boxes are messy. People mix constraints and preferences in one line. They will write brand names and colors and say under a price and ask for the newest item. If your search layer treats that whole line as plain text, you lose precision and you deliver inconsistent results. Parsing query intent into two parts fixes that. Strict filters for must-have constraints and boosts for soft preferences like proximity or recency. At a high level, think of filters as scissors that cut the result set down to what the user explicitly asked for. Think of boosts as magnets that pull preferred items higher in the ordering, without excluding anything. Success looks like fewer irrelevant items and happier shoppers, often with noticeably better first-page results. We will build a tiny end-to-end demo. It shows parsing a phrase, inserting a couple of products, applying filters, switching sort for recency, and finally, soft boosting a nearby item. The code is small and focused, so the ideas translate directly to a production system. Now we create the seed index and confirm the client talks to the server. This snippet connects to a local Elasticsearch node and creates a tiny seed. The variable ES holds the Elasticsearch client, which talks to the running server. We insert a single product with fields that matter for e-commerce: brand, color, size, price, and a timestamp for recency. Then, we refresh the index so the newly indexed document is searchable immediately. Finally, we count documents and print the result so you see a concrete success signal. Seeing docs equals 1 confirms the client is live and that our index already contains structured fields we can filter and boost against next. Next, we extract structured intent from a user phrase. This snippet extracts structure from a user query using the Python RE module. The variable Q is a realistic free text, like Nike Red under $100. We search for an under $N pattern to capture a maximum price and store it in the dictionary F as a 2-element range. We also scan for a known brand token, normalize it to lowercase, and place it under F brand. The structured dict is our bridge from intent words to exact filters. If you widen the brand list or price expression, you'll recognize more intents at the cost of slightly slower regex matching. The printed brand shows the parser captured the intended constraint. Now we will turn that parsed intent into strict filters against the index. This snippet turns parsed intent into exact Elasticsearch filters. We add a second product so the filter action is visible, then refresh inline. The variable col is parsed from the earlier query Q to capture the requested color. We build a bool query with 3 filters: a term on brand from the parse dictf, a term on color from col, and a range on price using the parsed ceiling. Elasticsearch evaluates filters efficiently without scoring, shrinking the candidate set to exactly what the user asked for. The printed hits value confirms only matching products pass, which is a direct precision lift over plain keyword search. Next, we detect recency language and change sorting to favor newest items. This snippet detects recency intent and switches Elasticsearch sorting accordingly. The variable Q2 introduces words like new or latest and has new flags their presence. We keep the same precise bool filters for brand and price, but change SRT to TS desc when recency is requested, or price.asc otherwise. Then, we request only the top hit, so the effect is obvious on screen. Increasing the range window or number of return hits will add recall, but may blur the visible effect. Reducing it keeps the demo crisp. The printed, sorted by, and top TS show recency activated, moving the freshest item to the top. Now we show a soft location preference instead of a strict filter. This snippet translates "near me" into a practical location boost. We annotate one product with a city and keep using our parsed brand and price filters for precision. The bool query's should array adds a boosted term on city equals SF, which increases scores for local items without hard filtering them out. That lets you combine strict constraints with soft preferences in a single request. You can raise the boost to make proximity dominate or lower it to keep relevance more balanced. The printed top name shows a nearby match wins ranking, completing a baseline that mixes filters and boosts for measurable precision. This tiny demo maps directly to a real product search flow. Replace the local index with your catalog index, expand the brand and syntactic patterns, and swap the simple city term for a geo-distance feature. The structure stays the same. Parse intent, apply strict filters, then apply soft boosts or alternative sorting when the user signals preference rather than requirement. Recap in 3 crisp points. What it is: a pipeline that extracts, filters, and boosts from free text, so search behaves more like a user asked. When to use it: when queries mix hard constraints like price with soft preferences like recency or location. One caveat: regex and hand rules scale well for many cases, but need maintenance and expansion as your vocabulary and product mix grow. Next step: tune the boost weight applied to the location should clause, and measure ranking changes with a small holdout set. Increasing the boost will make nearby items dominate. Lowering it keeps textual relevance stronger. If practical, hands-on IR helps. Subscribe and watch the IR videos.